Well, so we are going to start the polar plot. In polar plot, what we plot is nothing but the magnitude of Gj omega, Hj omega and angle phi, that is angle of Gj omega H. Means what we are going to plot magnitude and Gj omega, Hj omega and angle phi, that is angle of Gj omega Hj. We have also plot magnitude and angle in our board plot, but here rather than taking the semi log sheet, we will plot it directly. Okay, so we will have to map one of the table like this. The first table is for omega, that is angular frequency in radian per second, then magnitude, say Gj omega, Hj omega mod, okay, and then last one is phi. Angle I have already written Gj omega Hj. Correct? Okay. So all these things we are going to plot. So we are going to start if omega is equal to 0. Correct? So if omega is equal to 0, suppose the magnitude, you will calculate the putting the value of omega that is equal to 0, you will get some magnitude. I am going to name that magnitude as m0. Well, again, what we will do? We will find the angle phi, and I am going to name this is phi 0. Then suppose we are having the frequency domain axis like this. So it is similar to the polar plot you might have studied in your 12th standard or 11th standard. So if you have some magnitude m0 and some angle phi 0, it is a unique point. Okay, it is a unique point here. Unique point means with magnitude, say this is magnitude, I am going to say this one is m0 and this was is the angle in anti-clockwise direction with the real part. So you will get m0 phi 0, I am going to say this is point p0. Correct? Once again, if you will take omega is equal to rather than taking 1, I am going to say omega 1. Okay? So correspondingly you will get magnitude m0 and phi angle phi. So once again it will be some another point here. Say it is p1 with magnitude I am writing here m1 and phi 1. So this is a unique point. This is a unique point. Sorry, m1. Okay, magnitude m1 and argument phi 1. So you can represent this point like this. This is your phi 1. Okay, so we get another point. So if you try to connect this point, you will connect like this, and you will get a certain direction because you have started moving from omega is equal to 0 to omega is equal to 1. So you will get certain direction. This is the direction. So once again take another point omega 2, corresponding magnitude I am going to say m2, corresponding angle I am going to say phi 2, and say here it is the corresponding point I am going to say p2 with having magnitude m2 and argument phi 2. So once again here, and then connect this point also. So you have connected this point. Correct? Now take omega 3. You will get m3 and second you will get phi 3. Say it is p3 with m3 and phi. Okay, m3 is the magnitude, means length of this particular magnitude, and this is your angle with positive direction. Okay, so once again you try to connect this graph with the direction. Since we have moved from P0 to P1, the direction of arrow is towards P1. Once again from P1 to P2, direction of arrow is like this. And if you keep on moving likewise, where omega tends to infinity, you will get some magnitude m infinity, you will get some angle phi infinity. So suppose somewhere like this, okay, p infinity is m infinity and phi t. So if you will try to trace point by point by taking the sufficient number of points such that you can define your nature of curve, then whatever you will get, it is named as polar plot. Okay. But the problem with this is that means how many points are required to plot the smooth plot, polar plot. I am just going to say that I am going to take just 2 points in the most of the cases. The point is this one, okay, and second point is this one. I am going to say these 2 points are sufficient enough to tell you about the nature of your polar plot. First of thing is that in which things you are interested. You are interested in the omega GC, omega PC, gain margin and phase margin with the help of polar plot. So no need to plot the polar plot point by point. Rather than plotting point by point, just 2 points where omega tends to 0 and omega is equal to 0 and omega tends to infinity are sufficient enough to describe the nature of your polar plot. Correct? So how these 2 points are sufficient enough to describe the nature of polar plot, we are going to see. Before this, take one notice. Suppose you are going to move from P0 to P1. I am going to erase this and zooming in this particular thing. Okay, here it is, say it is P1. Okay, this is M1 and no, it is P0. This is M0 and phi 0. First thing, or just take P1. Okay, M1 and phi 0. Okay. And second one I am going to say this is your P. M2 and phi. I have taken 2 points in consideration. This magnitude is M1, angle is phi 1. Once again, this angle is phi 2 and this magnitude is M. If you will try to notice, then you will find that whenever there is a movement from P1 to P2, whenever there is a movement from P1 to P2, the angle difference you can say you will get somewhat like phi 2 minus phi 1. The angle difference you will get phi 2 minus phi 1. Correct? If I am going to say if this phi 2 minus phi 1 is positive, if this phi 2 minus phi 1 is positive, then their movement in this plane, in this polar plane, will be anti-clockwise. Correct? Like here we have taken phi 2 greater than phi 1. So phi 2 minus phi 1 is positive. So direction is anti-clockwise. Okay? But if phi 2 minus phi 1 comes out to be negative, your direction will be clockwise. Means movement will be like this and this M2 will be somewhere here and the movement will be clockwise. So this is the basic fundamental. So first thing is that now we are going to take these 2 points only. So first thing is that erase all these tables. Okay. Just take omega, back this table omega m phi, but take omega is equal to 0, find m0 and phi 0. Correct? Then take omega tends to infinity, find m infinity and phi infinity. Correct? Okay, I am writing it here. Omega tends to infinity because you can't take directly omega is equal to infinity. m infinity and phi infinity. Find the angle difference. Delta phi means final point minus initial point. Delta phi is equal to what? Will be phi infinity minus phi 0. Okay, and if it comes out to be positive, once again it will be counterclockwise or anti-clockwise. So just use rough approximation. This is for direction, and just use rough estimation and move in anti-clockwise direction with delta phi. This thing will be clear when I will take one example. So I am going to take one of the example that says that sketch the polar plot of the function gs is equal to 1 plus st. So one question is there. For example, I am going to take a question. We have to plot, you have to sketch the polar plot for this particular transfer function, where transfer function given gs is equal to 1 upon 1 plus st. Correct? So our job is to first find gj omega. So gj omega will be equal to what? 1 upon 1 plus j omega t. Then first find magnitude j omega mod for any, this is for, I am going to say this is m, for any value of omega. The general expression will be like 1 plus omega square t square. Correct? And if you try to find angle phi, you will get j omega will be somewhat like 10 inverse omega t. I have not assigned any value of capital T, rather I am taking t as a general time constant. You can have rather than 1 upon 1 plus 2s, the value of t is 2, or just 1 upon 1 plus st, the value of t is 1. So now our next job is to prepare the table. Okay. Omega is equal and magnitude and phi. Okay. So when omega is equal to 0, put the value of omega is equal to 0 to find the magnitude. So when omega is equal to 0, what is the value of m0? We have said that m0 will be some quantity. So where if you put the value of omega is equal to 0, this whole term will be 0. So 1 upon root under 1, that is 1. Magnitude will be 1. When omega is equal to 0, what will be the value of this phi? If you put this 0, this will 10 inverse 0 with negative sign. Whether it is negative or positive, 0 is 0. Correct? Now, we are going to take when omega tends to infinity. Leave a space between them. But I have some purpose to solve. So when omega tends to infinity, if you put the value of infinity, or you will take the limit when omega tends to infinity, it will be same 1 upon root under 1 plus some infinity. 1 plus infinity is infinity. Root under infinity is also infinity. 1 upon something infinity is equal to 0. Correct? So this will be equal to 0. And if you will take this angle, 10 inverse infinity will be 90 degree. Here it is negative sign, so it is minus 90 degree. Now the next point is that to find the rotation. What will be the rotation? Tell me.
Minus 90
Clockwise. Clockwise. So you will get, means it is phi 2 minus phi 1 like of thing. So delta phi is minus 90 degree minus 0. We are not interested in the magnitude of delta phi, rather we are interested in whether it is negative or positive, because we are interested in finding the direction, that whether it is clockwise or anti-clockwise. It comes out to be minus 90 degree, that is negative, that is clockwise. Okay. Now we want to sketch the polar diagram of this system with the help of these 2 points only. We have found the magnitude at omega is equal to 0 and phase corresponding angle, and once again we have found the magnitude and phase. And we have also found that the direction, whatever may be the curve, but the direction of movement of this curve from omega is equal to 0 to omega tends to infinity is going to be in clockwise direction. Okay. So now let us take this is, I am going to say this is real part of Gj omega Hj omega. You know that this is real part of Gj omega Hj omega, and this is imaginary part of Gj omega Hj omega. Correct? So first point we want to look in. First point is what? First point is when omega is equal to 0, magnitude is 1. Okay, so we are going to scale it. Here say it is 1. Okay, so here it is omega is equal to 0, magnitude is equal to 1, and phase is equal to 0 degree. So real axis, the angle with real axis is 0, so this point will lie here. Correct? And then when omega is equal to infinity, this is for omega is equal to 0. When omega is equal to infinity, the magnitude is 0, so it will be origin itself. Okay, but the angle is minus 90 degree. Okay, but you know that the omega you can't put omega is equal to infinity. Rather, you will take omega tends to infinity. So it will tends to 0, and the angle will tends to minus 90 degree, because if you measure this angle in clockwise direction, it will become minus 90 degree. Correct? So I have taken this. So here, and this point is here. This. So in the vicinity of all these points, means omega somewhat less than infinity, you will get some magnitude which is not 0, but some angle which is closer to minus 90 degree, but not exactly minus 90 degree. Once again, this curve is going to start from omega is equal to 0, and it is going to move clockwise. Okay, that's why I am written clockwise here, clockwise, and it is going to touch this. Okay, so you can see if your analysis is good enough, then with the help of just these 2 points, you will be able to sketch polar plot. Now note once again these 2 points, that omega is equal to 0, magnitude is 1, but angle is 0. So just suppose the second point is 0.1. So the magnitude will be almost equal to 1, somewhat whatever it may, but almost equal to 1, but the angle will be smoothly, because it is going to decrease, it is going to move in clockwise direction, so it will be somewhere like this. So it will be smooth. Note it here. It will not be sharp like this. Rather, it will be smooth like this. Here, smooth. Try to note the curve. Okay. And here it is minus 90 degree line, so it is smoothly going to collapse into poles. Right? So this is the way how you can find or you can sketch the polar plot of a given system. Okay. After sketching, the job is that how to find omega Gc, what information you can extract from the polar plot of a given system. We have extracted information like omega Gc, omega Pc, gain margin and phase margin from the board plot. Similarly, we are going to extract this information from the polar plot also. Why this information are necessary? Because we are interested in whether the given particular system is stable or no, and what are the phase lag which can be additionally provided to the system till the system goes to the verge of instability, and what are the gain which can be added to the system till the system becomes unstable. So the next topic is omega GC and omega PC in the polar plot. Means how to define omega gain crossover frequency and phase crossover frequency in the polar plot. I have taken two examples, but I am going to focus on this first example first, and then we will move to second example. And you have to conclude with the information provided by me that whether this curve or this curve both are unstable or both are of a stable system or whatever it is. So first thing is that we are going to plot. Here we have plotted like this. So suppose it is a hypothetical polar plot of a given hypothetical system, which is going to start from omega is equal to 0, this point, okay, and it is going to move like this in this direction and like this, and at omega is equal to omega tends to infinity, it is going to end at the origin. Suppose this is a hypothetical diagram of a given hypothetical system, correct? So first job is that draw a circle of unit radius. Okay, this is a circle of unit radius. Here, this one dotted line is a circle of unit radius. Why we have drawn the circle of unit radius? Because we want to know the gain crossover frequency. From the previous knowledge of gain crossover frequency, we know that the gain crossover frequency is the frequency where the magnitude of Gj omega Hj omega is equal to 1. While discussing the Bohr plot, we were interested in the magnitude in terms of decibel. So we have defined that magnitude equal to 0 dB, but absolute magnitude is equal to 1. So with the first we have to trace the unit circle. Okay, now see. This graph is going to start from omega is equal to 0 and it is moving in somewhat whatever may be the direction. We are not interested. Here it is clockwise. Here it is clockwise. We are not interested for the time. So it is going to cross the circle of unit radius at point P. So what is the meaning of this? At point P, the magnitude here, the red line. The magnitude of the given system for which I have plotted the polar plot is equal to 1. The magnitude is equal to 1. It means that the corresponding frequency will be nothing but omega Gc, because it is omega is equal to 0. This point say it is omega is equal to omega 1, omega 2, omega is equal to omega 2, omega is equal to omega 3. Some value of omega must be associated with the each point of your polar diagram. But we are interested in this particular point. So this particular must be associated with some given frequency. So I am going to say this is omega is equal to omega Gc, because we have just found that it is the gain crossover frequency where the gain becomes unity. Correct? So I have written this at this particular point at omega is equal to omega Gc, mod of Gj omega H omega is equal to 1. Correct? Next, this graph will keep on moving. Correct? At a particular point, or once again at a particular frequency, it is going to cross your negative side of real axis. Correct? That's why I have written it is minus 180 degree, because if you will take this angle from here to here, it will be minus 180 degree. Or here, we are moving in this particular direction. We are taking the angle in clockwise direction. So if you will take this here to here, it will be minus 180 degree. That's why it is minus 180 degree line I have written. The negative side of real axis I am going to say it is minus 180 degree line. So whenever your polar plot is going to cross the minus 180 degree line, or you can say the negative portion of your real axis, it will be the corresponding frequency will be nothing but omega is equal to omega Pc, that is phase crossover frequency, and this particular frequency I have written that angle of Gj omega H omega is nothing but minus 180 degree. Correct? That's right. So this is omega is equal to omega BC, omega is equal to omega DC. These two information we have extracted. Now we know that the phase margin is defined. Phase margin is given by 180 degree plus angle of Gj omega Hj omega at omega is equal to omega Gc. And I have said that all the angle we are measuring in the clockwise direction. So this is the your at omega is equal to omega Gc. So we are going to say this is corresponding phi angle, or you can say phi Gc, corresponding phi Gc. Or you can say no corresponding phi Gc, and also say corresponding phase margin. What you can say? Corresponding phi, just phi itself. This is the value of angle at omega is equal to omega Gc, phi. So this will be some negative quantity, correct? Plus 180 degree, some negative quantity which is less than minus 180 degree. Whatever it may be, but less than minus 180 degree. Plus 180 degree will be equal to some positive quantity. So if you will try to locate that, if you will try to use this formula of phase margin is nothing but 180 degree plus angle at omega Gc. Angle at omega Gc is nothing but I am going to say it is phi dash. I am going to say it is phi dash. So 180 degree plus phi dash will be some positive quantity. So here if you will try to locate this, you will get this angle, because 180 degree line it will be minus 180 degree line. So 180 degree minus this phi, you will left with this particular margin. This. So if your angle is below real axis, like I have depicted this particular case, you are going to say this is your positive phase margin. So that's why I have written this particular angle is the value of phase margin, but it is positive phase margin because it lies below real axis. This is the convention for your polar diagram. So this is your positive phase margin, correct? Now coming to the gain margin. Gain margin is defined as 1 upon Gj omega Hj omega at omega is equal to omega Pc. At omega is equal to omega Pc, the corresponding point is Q. So at Q, you are interested in finding the magnitude of your given system. So magnitude will be equal to what? Means Gj omega Hj omega at omega is equal to omega Pc. Omega magnitude will be nothing but this value, this length, or you can say the length of OQ. So 1 upon length of OQ, OQ is the line, will be your gain margin. So here is the unit circle. So this point I am going to say nothing but minus 1. This point is minus 1 plus J0. This point means the intersection of unit, the circle of unit radius with the negative half of the real axis will be nothing but minus 1 plus J0. So magnitude whatever you will get in this particular curve means value of OQ will be somewhat lesser than 1. Lesser than 1, the magnitude will be lesser than 1, maybe 1 by 2, 1 by 3, whatever it may be. So the corresponding value of gain margin will get somewhat more than 1. Okay, so gain margin is positive, and here also phase margin is positive. So whether this graph belongs to a stable system or not. So this particular system is stable. Second convention, with the help of second convention, the stability says that with help of omega Gc and omega Pc, whenever omega Gc less than omega Pc, your system will be stable. This was the second notion of the stability we have defined with the help of, just with the help of omega Gc and omega Pc. We have defined two cases. Whether both of the gain margin and phase margin are positive, then we are going to say your system is stable. If you will take the logarithmic, means if you will take on the dB scale, means this is greater than 1. This gain margin, absolute gain margin is greater than 1. Then log of 20, log of that some quantity greater than 1, it will be positive. So both gain margin is positive, phase margin is positive. Once again the system is stable. And here you are going to encounter omega Gc first, means moving from 0 to infinity, you are going to encounter omega Gc first and omega Pc later. It it means that omega GC is less than omega PC. With the help of this convention also, your system is just stable. Now coming to the second example, it is your first example, coming to your second example, what you can conclude? Okay, so this OQ, first see, here the angle is, here angle phi dash is somewhat greater than 180 degree in negative sign, negative with negative sign. So your phase margin is going to be negative because it is 180 degree plus phi dash, and phi dash is negative quantity which is more than minus 180 degree in absolute in magnitude term with a negative sign. So it will be negative phase margin. So your angle will be shown here, and this is your you can say what gain crossover frequency omega GC. This is your omega PC. This is your omega 0, then omega PC, then omega GC, then infinity. So here you can say denote this particular angle is a negative phase margin. Now coming to the gain margin. Here, this point Q lies outside the unit circle. It means the value of OQ is more than 1. It may be 2, it may be 3, whatever it may be. So gain margin is defined as 1 upon that length. So 1 upon that length will be smaller than 1. And if you will take the in dB term, it will become negative. Means log of some quantity which is less than 1 is negative. So gain margin become negative, phase margin also become negative. So with the notion of gain margin and phase margin, this your system is unstable. Correct? And again with the second notion, your omega PC is less than omega GC. Omega PC is less than omega GC. So once again with the crossover frequency, you can also say with this help, with the help of this frequency, you can also say your system is unstable. Correct? And in the marginal case, it will pass with this. Correct? So this when even omega GC will be equal to omega PC, you can say your system is marginal case. This particular your curve will pass through -1 plus J0 point. Okay. So without tracing the circle of unit radius, you can say this -1 plus J0 point is very important in the analysis of polar diagram. Okay. So whenever your graph is going to enclose -1 plus J0 point, you can say your system is going to be unstable. By the meaning of enclosure is that when you are going to move from omega is equal to 0 to omega is equal to infinity, if -1 plus J0 point lies to the right side of this, whenever the graph is going to cross through the unit circle, means the intersection point of this unit circle and -180 degree will be equal or will be the same point, you will say your system is marginally stable. At this point you can say omega GC is equal to omega PC, because this will also belongs to -180 degree line and also belongs to the unit circle. Correct? So we have concluded that this -1 plus J0 point is very important in the analysis of polar plot. Why? Because rather than tracing this the circle of unit radius, I am going to define this concept in another way. I am going to say that if -1 plus J0 point is enclosed by your polar plot, your system will be unstable. If it will pass through -1 plus J0 point, it will be marginally stable, right? And if it is not going to enclose -1 plus J0 point, your system will be stable, correct? So what is the meaning of this? Without plotting circle of unit radius, if we know the intersection point is here, and if you know that -1 plus J0 point is here, red one. Correct? 3 examples I am going to use. But first, I have to define the meaning of enclosure. A point is said to be enclosed by a polar plot if you are going to move from omega is equal to 0 to omega is equal to infinity, and if that point, and here we are interested in that is -1 plus j0. So if -1 plus j0 point lies to the right side of the plot, you are going to say your point is enclosed by your graph. Suppose this, if you are going to move from omega is equal to 0, omega is equal to 0, omega is equal to 0 to omega tends to infinity. So this point, I am going to say this is 3, this is 2, this is 1. So -1 plus j0 point is this. So when you will start from moving along the graph number 3 with the increasing value of omega, means from omega is equal to 0 to omega is equal to infinity, you see that you are moving in this way. You see that your -1 plus j0 point lies to the right side of your path of traverse. So you will say that -1 plus j0 point is enclosed. It is closed by your polar diagram. So you will say this type of system is unstable. Okay. Without finding anything, just with the help of enclosure of -1 plus j0, you can conclude that whether your system is stable or unstable. Once again, second graph is number 2 passes through -1 plus j0 point itself. So it is for marginally stable. And the first curve, if you see the first curve, -1 plus j0 point is not enclosed by the first curve. So you will say this is stable. Stable. Okay. Now move to the other face of point. We know that whenever it can increase, whenever the value of gain is increased, your system moves towards instability. This is a well-established fact. I have dictated it many times, and I have also proved in the lab with the help of simulation of a system in P3. Correct? So whenever the value of gain K is increased, your system tends towards the instability. Correct? So suppose here we are varying the suppose you are having a system. Means I am going to say, since the nature of all these three curves, all these three polar plots are same. Okay, so I am going to say this is for particular specific system. I am going to say GSHS is equal to some quantity in numerator and some quantity in denominator, just for example. And here gain K is there, and nothing is being varied because the nature of graph is same. How you can conclude? Because you know that nature can be defined by omega is equal to 0 point and omega tends to infinity point. So nature of whole this curve is there, but the only difference is that some of these pass through, one of these pass through -1 plus j0, one is enclosing -1 plus j0 point, and another one is not enclosing -1 plus j0 point. That is the only difference. But if you will try to plot with the help of this convention, this 2-point convention, you will get the same. Later you have to define this particular point with the help of putting the angle. The argument is equal to -180 degree, and then finding the value what is the value of omega. Correct? So I am going to say here K is a tunable parameter and the rest everything is constant. So for graph 1 I am going to say this is K1. For graph 2 I am going to say gain is K2. For graph 3 I am going to say gain is K3. So what you can conclude just for the relationship between K1, K2 and K3 just by seeing this graph. Just can you say that K3 is greater than greater than k. Why? Because you know that with increasing gain k, your system tends towards the verge of instability. Correct? Okay. Now moving to this question once again. I have said that you have to leave one of the point, means you have to leave the gap, one of the gap. So suppose you are not able to find, or you are having confusion that whether it is graph is going to move like this or not. So take one of the intermediate point. For the sake of convention, easiness, I am going to take 1 by t as a value of omega. So by taking 1 by t, what will be its magnitude? Because t is not given, that's why I have taken a point such that omega t is equal to 1. You can say omega t is equal to 1, or you can take equal to 2 or equal to 3 likewise, such that there is a direct correlation between omega and t. So omega t is equal to 1 I have taken as an intermediate point. It means that omega is equal to 1 by t. So the magnitude will be, if you will put omega t is equal to 1, it is 1 upon root 2. 1 upon root 2, 0.707. Okay. And what will be the angle? What will be the angle? Tan inverse 1 is 45 degree with negative sign. It is minus 45. So suppose you want to check the validity of your curve, that whatever you have escaped at a polar plot of a given system, whether it is correct or wrong. So for your sake of convenience, for your confidence, you can take an intermediate point. And with the help of intermediate point, you can locate this intermediate point and going to say this magnitude is 1 upon root 2 and this angle is 45 degree. So our convention was correct because still it is minus 45 degree. So the movement is same. There it is 0, minus 45 and then minus 90. Correct? Okay. Well, so it seems that the polar plot is very good enough for the analysis purpose because we have no complexity of semi-log and all those things. Directly you have to plot the magnitude and phase, and you can just look at the minus 1 plus j0 point and define whether the system is stable or not. It seems to be easier than that of board plot, but there is a catch. So what is the catch? Suppose you have traced a plot point by point. Okay, you are going to trace a plot point by point, and unfortunately you are going to start from omega is equal to 0, moving like this, and once again moving like this, here, and you find thus minus 1 plus j0 point is here somewhere like this. Okay, at omega. Though the cases where we have been asked to plot the polar plot with the help of this 2 point, we will not be able to get curve like this, but of course this case will be simpler where the analysis will be relatively easy. That's why I have taken the 2 point convention to plot the polar curve. But suppose for a case whether though the case may be rare, but suppose you are getting a curve like this, may be possible for some system. So now for such type of system it is very difficult to define the inclusion of minus 1 plus j0 point. Also this particular curve is going to cross minus 180 degree line at 1, 2, 3 points. Okay, and you can have the analysis difficult for such type of system. Okay, so if such type of cases arises, your polar plot will fail to analyze how to find the stability. Then the answer to this complexity is nothing but Nyquist plot. So we will try to explore the Nyquist plot in the coming classes. But before that, I would like to take one of the more example. Means I am going to say inverse polar plot is also there in your syllabus. So I am going to say that the next topic is inverse polar plot. Just I am going to start with a question that sketch the inverse polar plot of GS is equal to 1 plus ST upon ST. Correct? If the word inverse is mentioned in your question, it is nothing but you have to plot G inverse S, and the rest of the analysis is similar to that of polar plot. So I am going to say in solution you have to plot G inverse S, or you can say 1 upon GS. So what you will get ST upon 1 plus ST, and by putting S is equal to J omega, you will get G inverse J omega will be equal to J omega T upon 1 plus J omega T. So what will be the magnitude? Magnitude will be omega T divided by 1 plus omega square T square, and phi will be equal to 90 degree minus 10 inverse omega T. Why 90 degree? Because in numerator there is a term of J omega T, and we have taken T as a positive and omega as a frequency, that's why it is a positive quantity. Correct? So the rest of the analysis will be similar. Means we will draw a table consist of omega, then magnitude m, and then phase phi. You will take omega tends to 0 point, you will get 0 as a magnitude because 0 divided by 1 is 0. Okay, here 0 divided by 1 is 0, and the angle is, this is 0, tan inverse 0 is 0, so angle will be 90 degree. Correct? When omega tends to infinity, what you will take? Magnitude 1 and angle 0. So inverse polar plot is nothing but you have to take the inverse of your transfer function. Just your numerator will become denominator and denominator will become numerator, and the rest of the analysis is similar as the polar plot. So let us try. At omega is equal to 0, angle is 90 degree. So this angle is 90 degree. Magnitude is 0. So your graph is going to start like this. First you have to find the angle conventional. So angle convention gives it what? 0 minus 90 degree is equal to negative. So negative means what? Clockwise. So your graph is going to start like this, or it will move here in this way, clockwise, this way. Because if it will move like this, it will become anti-clockwise. So your graph at omega is equal to 0, magnitude is 0, angle is 90 degree. Your this corresponding point is here, and your graph is going to move in this direction because 0 minus 90 degree is equal to minus 90 degree. That is negative. Correct? Now, at omega tends to infinity, magnitude is 1. Here suppose it is 1. M is equal to 1. I told you. This value is 1. Up to here. Magnitude is 1 and angle is 0 degree. And movement is negative. So your graph will move like this and go to a smoothly like this. Correct? So this is your inverse polar plot. This is nothing is new here, except that you have to take the inverse of your transfer function. The rest of the analysis is same. And once again, if you are having any confusion, you can take any intermediate point such that omega t is equal to 1 or omega t is equal to 2 or 10 or whatever it may be. You have to take like 1 by t, 2 by t, 10 by t, and then you can be conformed about this particular curve. Okay? So So in the next class we will see the frequency response of the system, similar to that of time response. We have analyzed enough about the time response properties of the time response, similarly like maximum overshoot and all those times, means peak time and settling time and all those times. So what are the corresponding frequency domain parameters? We are going to analyze, whether there is a correlation between this time domain parameter or frequency domain parameter or not, and if yes, then what are those correlations? We will analyze those correlation and then move to the next part. I think that is very important. Okay.